This is made up of wires, and we are decompiling Castlevania Symphony of the Night. I said I wasn't going to be here today, but I got some free time, so I figured I'd hop on and go over some of the events of, I don't know, the past couple days. I need to review some stuff myself. There's been a lot of activity, and I have been off doing other things, and so I don't necessarily know what the current state of the art is. If you are not familiar with the Castlevania Symphony of the Night decompilation project, we are working on creating code that will compile back to various versions of Castlevania Symphony of the Night, primarily the PlayStation version, but also the PSP version, a mysterious early build of the PSP version called HD, or hard disk is what the assumption is, as well as looking at the Saturn and Xbox 360 versions to a lesser extent. I had been working primarily on weapons, and if you were watching it all last week, I was struggling through the last function in Weapon 30. We are down to one weapon remaining in the first weapon binary, and it looks like Roaming, who is a regular in the chat during live streams, he's at about 90. What is it? Let's look at his 96%. And so what I thought we'd do today, he's done significantly more work on this than I have, so I'm not going to steal any credit or thunder from him. But what I would like to do is look at where we were on our PSP version of this function and the PlayStation version, and do a diff between where we were last week and what Roaming has worked on, and kind of see where were some of the pitfalls, and hopefully learn along the way. I'm going to pull up stats just so I know what is going on, if I can find it. Hey, Dig Down Deep. Good to have you. I did say I'd be back on Wednesday. I got a little bit of free time this morning. This one will be a little shorter, and I don't have anything planned really because I didn't think I'd be here today. But yeah, I'm just gonna quickly go over this Weapon 30 and then maybe talk a little bit about what I've been working on offline as well. And I will be back on Wednesday. I've realized as well, I'm going to be out next week as well. So I wanted to get as much time streaming in as I could before having to take even more time off. All right, so let's look at what I'm going to do is take the version of Weapon 30, this second function of Weapon 30, and it's been a while since I worked in weapons. I'm going to put my broken version in and get that compiling, and then I'm going to replace it with Roaming's version. Right, copy and paste would help. Let's make sure this compiles, and we can do a diff there and see what has changed. So there was a few things that changed since we started this scratch. One being the renaming of this field. So we got to get the new name of that field in here. Let me grab what that was. This was on line 201. So the player entity, or the player structure, sorry. And let's see what that was here. So while I'm looking this up, so this looks like it was timers. We need to timers. And I might have to do that when we import roamings as well. And then one more. So we have this 74054. Let's see if I can find what that is. So that is an entity. Oh, it looks like possibly just a declaration that I don't have. So this is the last remaining function in weapons. Will this compile, or will I get a link error? Okay, so that failed. That's expected. I would like to see. My guess is that Josh is. Yep. So Josh had this finished. We talked about this last week. This was the last function, or this function had been completed. There was a completed scratch, and so now it's checked in. So last week we were at 2 functions remaining. And then now we're down to the last one here. This obviously failed. We know it's not a match yet. So what I'd like to do then is go back over to roaming scratch. Actually, I'm going to add this to my stage it in Git. And then let's see what we need from this one. So we have these slightly different declarations. So I'll just grab everything. Make sure we can build. And so we have the same issues here. This is going to be timers. And then that entity declaration. Okay, so this also isn't a match. It's 96% of the way. Let's look at some of the differences here. There may be differences related to superfluous things, such as, so the first one I see here, this. So I had these declared on the same line. Roaming took them out, put them on separate lines. It looks like he's putting the registers names next to the variable to help identify which variable that is going through. And so it looks like some other reordering of variables. And again, so this one of the things that was an issue in this particular function was some of the register pressure was forcing things back to the stack, but also things weren't necessarily in the correct order on the stack. And one of the ways that we can coerce the order for elements on the stack with the MetroWorks compiler is by reordering how those variables are declared. So the stack variables more so than the register variables. And I've said this before, but we don't necessarily control if variables are going to be on the stack or the register. The compiler will look at that, decide, I'm using this a lot. I don't want to have to keep writing to the stack and pulling back into a register. The MIPS CPU is only able to operate on data that's in registers. So it has to load data from memory, or in this case, the stack, which is in memory. It has to load it into a register, do some operation, and then store it back to the stack. So that is 2 extra instructions for stack variables compared to register variables. When you look at an optimized GCC version, you'll see things pulled into registers, used for a while, stored back onto the stack, not necessarily in the same place, and then that register being reused for other things. That happens less so in the MetroWorks compiler. He got rid of these superfluous variables that I hadn't gotten to yet, which makes sense, or some of them look like they were reordered. I'm mostly looking for code and seeing if there's code differences here. So the change here is I had introduced the brightness variable to force a particular assignment that was happening, and the way that this was restructured then, that assignment was no longer needed. And that makes sense. So this kind of multi-assignment, the compiler can say, okay, I know this immediate value, OX80 or hex 80. I'm going to need that to assign to several of these fields. So instead of assigning an immediate value over and over to all these fields, I'm going to just stick that into a register and then assign that register to different fields. Looks like a slightly different draw mode between PSP and PlayStation. Draw mode is flags that are used to affect how items are drawn. Some reordering here. So V, we could go back up and see if the type for V changed, but it looks like the mask is not necessary, and some reordering then of the fields. It's curious, I think, that between the two lines, the multiply by 8 is in a different order. I'd be interested, I think, in going and looking at that on the PSP side and seeing how reordering that affects the instructions. Anytime there's like inconsistencies between very close lines, I'm a little surprised how that might happen. The way that most of it definitely does happen, but the way a lot of the code is written, it's pretty symmetrical from line to line. The check that I did a few minutes ago, this one where, let's see. Are you talking about this check here where I get okays and fails? Yeah. Yeah. So this is just a SHA check, SHA-1 check of the produced binary versus the original binary. So we grabbed the SHA-1 hash of the original binaries and then do the check at the end. And then last week, I just added to our make file to kind of reformat this to make it very obvious when things fail. So it's just a SHA check, just SHA-1 or SHA-sum with the C flag, and that's what the output used to be. Okay, so continuing on, so in these cases where there's greater than equals versus greater than, that's something that I know I probably need to be better about. Usually that's what's used. So the instruction that's generated in this case might be let's see, GT. Let me find where this line is, and I'll grab the instruction. Actually, it might be a SLTI. Let's 147. Yeah, SLTI. So signed less than immediate. So even though we're doing a greater than, the instruction is assigned less than immediate, and the branch then is flipped around. Yeah, and that's because a human did write them. The originals are it was assigned less than immediate, and the decompiler is probably what originally produced these greater than equals. And if you look at the immediate values that are in the compiled instructions, the immediate value is a 9. And so when you look at that instruction, in my head, I would think, okay, I need a constant 9 in there. But then flipping those instructions around makes sense. Howdy, Project Omega. Good to have you back. And so along the way, so we're looking at roaming's code compared to what I had earlier. He's about 25, 26% closer to his match. And we can look at that and see if there's any progress we can make. Along the way here, and I find this useful as well, commenting what register we're trying to target, so that as we're going back through and looking at the assembly, anytime we see register S6, we know that this is going to be the X variable and can put that in there. I had split these up between 32-bit X values and 32-bit Y values, because often those are 16-bit values, and so I had both in play, but it seems like the only one was necessary. This is a interesting change here. So there were several of these that I was working through last week as well, where the decompiler decided that this was part of this set of colliders, and that we were pulling an offset in that set of colliders when it turned out not to be. It looks like these arrays are unknown, and so we'll have to see if those get used for anything. And some nice cleanup along the way. Okay, so this is another case where the way the decompiler interpreted this was to do a check against 0 first, and then set up the for loop. This would have come from the GCC decompilation, so the optimized decompilation. So when GCC is compiling and optimizing this, it's going to say an immediate comparison versus this offset is cheaper than doing all this other stuff. So I'm not even going to do the other stuff if I can get away with this cheap comparison and branch. And I'm going to have to load these things anyway. Because I'm loading this particular field at this pointer, and then I'm reading it again right away, I won't have to read that a second time. My one read will count. And then I'm going to, at the bottom of the loop somewhere, to make this consistent, I'll put in code to read that again, so the next time we come through the loop, that data is correct. When we look at the unoptimized version, that those nested for loops again make more sense, look more human. And I think the structure sometimes that the decompiler creates is so odd that for me, looking at those in comparison to how I would think about it as a human writing this, that translation doesn't make sense. I was watching a video, a recommended video. Hey, Tux can play. Yes, red is me and what I had, and mine is based on, I think, one maybe Josh started a couple weeks prior. So this was code that we had been working on last week, and then roaming had been working on this since the last stream and is quite a bit further along. So I just wanted to see what was going to be needed to be done to get closer and learn from his code along the way. So I was watching a recommended video, and it was about the Japanese words from Street Fighter 2, and are they actual Japanese words? And it was a Japanese speaker, obviously, translating, and what the English interpretation was, and some English transliteration that I hadn't heard about, Hadokens and different things like that. And it kind of makes me think about this, like the decompiler produces something, and when you think about it as a human and try to sound it out or try to follow it logically, the what you produce doesn't always make sense. But if you are a native speaker, maybe that would make sense. Native computer, it might make sense. So here a lot of this is much more simplified. And this happens a lot when the decompiler is creating loops. And it's possible that this could be even more simplified, and we can look at that as well. So when we have a loop that has a condition inside of it as well, is it actually a condition inside that loop? Or is it something that's happening as part of the loop condition itself? I'm not sure, just looking at the code, obviously. We'd have to look at the assembly. My guess is, though, that this is based on the PSP version, and probably is correct. But going up to the top and looking at what the decompiler produces, it's going to, again, this is from the optimized version, it's going to go through all kinds of contortions to optimize. And so it will do the minimal work necessary. Where's var A1? It'll do the minimal work necessary to make sure var A1 is initialized to the correct thing. And then in this version, that's not even getting updated again. So it's kind of obviously incorrect. But then when we look at, what a human now has reasoned through this and come up with more correct code, it becomes relatively obvious what's happening. And that's kind of the fun thing about solving these. They're puzzles, and the logic should make sense. Hey Everdread, the decompiled code for this is coming from M2C, which is a MIPS decompiler that's primarily focused on GCC. I'm not sure actually if the PSP version is coming through M2C as well. I'd have to look at that to see if we can switch over and see if that's coming from M2C. But M2C is used on a lot of these. Yeah, I'm guessing based on how this looks, that it also is based on M2C, which is an open source MIPS decompiler. M2C, MIPS to C. And so, again, if you're just joining, what we're looking at is last week. So this is the last function in the first weapon binary on the PlayStation version of Symphony of the Night. And we were kind of counting down over the last several weeks of the functions remaining that we're decompiling, and now this is the last one. I had left it at around 70-ish% complete, and Roaming, who's a regular contributor to the chat, has gotten it to 96%. And so I wanted to see what things that he had changed from last week. I've been a little out of the loop, doing other things that aren't Symphony of the Night, doing some things that are Symphony of the Night, but mostly not. And not other programming, having a life outside of streaming and decompiling. This is interesting, and I wonder if this. So we get a lot of this from the decompiler. And there's factory and weapon factory macros that'll do this bit packing for us. So the decompiler will produce some code that will do this bit packing. But we have macros to do that to make it more readable. And this is one of those. What we found with weapons is that the macro that's used in other parts of the game doesn't always work for weapons, and the way that they're packed or the way that the code is generated after they're packed is slightly different. And I don't know if this is a different version of that. What can I do here? Split. So I'm looking for this factory macro. Oh, come on, grep. So the main version of this macro just combines the ID that's passed in along with a param shifted by 16 bits. So it's taking basically two 8-bit values, or sorry, two 16-bit values and packing them into a 32-bit value. And then the weapon version, oh, where's weapon factory? It exists somewhere. Maybe it's in the weapon directory. Maybe it's factory weapon. No, I can't find it. I know it exists somewhere. Mush brain. Not finding it. Oh well. The weapon version is slightly different because weapons have this additional hand ID parameter that gets shifted by 12 bits. So packed into 4 bits at the bottom 16 bits. So this structure is mostly rewritten. This is interesting. Slightly incorrect for loop at the top of case 2. That's kind of odd. So unknown 8A wasn't ever being set, and the division and addition were on the same line. Okay. This is interesting. So primitives have 4 sets of colors. The primitives that are used in Symphony of the Night are quads. So we define 4 points in space. And then each corner can get a color associated with it, and the hardware will produce the gradient between each of the corners and across the different, using garage shading, I think. And so these are unsigned 8-bit values, the 4 colors. And the decompiler, and I mean, probably based on what the compiler did, was adding FA to this. So if you're a computer science student, computer engineering, and know how bits or how bytes are stored in signed and unsigned values, 2's complement, -6 would be represented as hex FA. So what we do is we write a 6, subtract 1, and then flip all the bits, and that's how we get the final value. And then adding or subtracting that value basically results. So subtracting the original value or adding this 2's complement value will produce the same thing regardless. And so there's some interesting things there. Most people who have watched or paid attention to Symphony tonight probably know about the underflow issues with the shop glitch. And that's kind of the same thing. So when we're subtracting a value from an unsigned number, depending on the sign and type and of the instructions, as well as what the code interprets it as, if it's an unsigned value, if we have 0 and we subtract 1, we'll roll over and basically get the equivalent of -1, but that equivalent of -1 is also, for if we're a signed number. For unsigned values, that's the max integer, which is how the shop glitch works. And so now you have either 255 or I think shop glitch is an 8-bit value, so I think 255. Otherwise, you get 16,000 of something, which is even better. So more of these less than equals versus, or greater than equals versus greater than, and some of these width issues. So Roaming did quite a bit of work finessing this. And these down here, this is just notes for data. So let's go back and we'll pull this over to the PSP and see if we can see where... oh, that's interesting. Only 87% on the PSP. We could kind of flip between the two and look as well. So what typically the PSP version is correct, and we need to try to get a match on the PSP, which is more finicky because it's not optimized, but also more linear, making it easier to reason about what's going on. And most of the time when we get a match on the PSP, we can take that over to the PlayStation and it will match as well. The PlayStation version is using standard optimization. Instead of the MetroWorks compiler, it's using GCC. There are many more permutations of how code might look that will all get compiled to the same thing after the optimizer pass. So there's some masking here, and this okay, so there's a few things going on. One, this value is being stored on the stack instead of in a register, which prevents us from, or gives us a bunch of additional instructions where we have to load things from the stack and then store things back from the stack. So this is at offset FF on the stack, and so we're going back and forth between that. It kind of looks like a mask, but in this case it's just an offset. In the original, we're taking the value that was stored in register S8 and then adding a value and masking it off. And the reason it's being masked off is because it's being used as an 8-bit value, but registers on MIPS are 32 bits, and so it has to make sure that it, after it does this addition, that it's still within the constraint and size boundaries of it looks like maybe a signed 8-bit integer. Let's see what V is. In this case, it's unsigned. Does that make sense? I don't think it will make a difference. Oh, I guess it would make a difference because that would be this would be a negative value in unsigned. Hey, Luigi's Evil. Yeah, I'm just doing something short today. Actually, I'm kind of running up on time, so I probably don't have time to go through and look at this too closely today. So let me share with you what else I was working on during my time off, and that might be of some interest. I'm going to go back to the terminal. So we have a bunch of overlays, and there's some discussion about what is an overlay last week. And we take things like stages, the player character, weapons, and when those are selected, so when you're switching, going through red doors, the stage is going to be loaded from disk, and those bytes are just going to be written to a specific place in memory and overwrite everything else there. That means there's probably some interesting things. We looked at a dangling pointer, or an uninitialized pointer that could have some interesting things in the Maria cutscene last week as well. But when that, so when that new stage comes in, it just plows over everything in that particular memory space. And so you're constrained at how, so why can't they load all of the characters in a particular stage, or why is it so hard to mod this so that we get Medusa heads in NO3 or NP3? And that's because there's only so much address space and physical memory available for each of these overlays to be loaded in. And when they load that, they have to load all of the texture data. They have to load everything, for tile maps for backgrounds, sprites for characters. And that ultimately becomes the limitation. The 1 megabyte of memory on the PlayStation becomes the limitation for what they can load in. And then those things are streamed to disk when you go through the red door rooms. So that's what overlays are and how they work. And so basically each of these binary files that we're trying to match is a different overlay. And so we have specific offsets and memory addresses that we're trying to match as we're splitting those up and coming up with code. How those overlays work between the PSP version and PlayStation version are mostly the same. But then you get into something like the Xbox 360 version, and the Xbox 360 version doesn't work that way at all. It will load sprite data from files, but it's more like a typical computer program where things are linked dynamically. Effectively, all the functions are loaded when the game is loaded, and none of the code is replaced at runtime. That's somewhat unrelated to what I was doing, but that's kind of why we talk about overlays and specific binary files. When we do get into the Xbox 360 version, there will be some issues with that based on how we've written things to share code, because the Xbox 360 version will just have multiple versions of that code, and they all have to be called something different because those symbols can't conflict. Let me figure out what branch I was at. So what I was doing off stream a lot last week was working on a new overlay. So there's a version of the game called HD, which is, it seems like an early port of the PlayStation version of the game to the PSP. And so when they're running on the PlayStation development kits and loading things off of hard drives, paths and other things like that are different from what they would be when the game is finally put on a UMD. And it's interesting because these files, these HD files, are now included in every subsequent version of the game, but it's not clear that they're used or ever loaded by any version of the game. So why are they shipped with the Android or iOS version of the game or the Requiem collection? That's a mystery that has yet to be solved, I think. So I was looking at the center stage overlay for HD. So these files are coming from, in this case, we're pulling them from the EU PSP version of the game. I haven't checked. I've been meaning to write a script to go through all the versions of the game and kind of match the binary files. Some of them will match exactly. Some of them are just relatively close. So like send.bin on PlayStation versus HD versus PSP, all three of those are going to be different. But it'd be kind of nice to know where those files exist. The paths are different. The more modern versions have very odd, like everything's kind of in a flat directory structure versus the PSP version. So when we're creating a new overlay, we use Splat to split this up. And I went over splitting this early last week as well. And we're given basically 4 segments that the file will be split into. And then we have to go through and split those into finer things as well as, or finer segments, as well as trying to match the code that we already have in cases where we can reuse as much as possible. So the 4 segments that we get from the tooling, and we can look at the header of the file and determine where these splits are. So we're looking at the data segment, which will be sprite data, just constant values that get loaded. Some of these are mutable, but often aren't mutated. RO data, which is static strings, jump tables, and other things like that for so data that has been declared to not be changing, and potentially could be, if you're on a system where you can set a read-only flag on that particular page, would be loaded that way. The text segment, which is code, and then BSS or SPSS, which is uninitialized data. And in this case, some systems, you just need to declare what the offsets are in SPSS, and that's not actually stored in a file. In the case of the PlayStation binaries, all of those zeros are stored as padding at the end, and that's mostly so that the loader can be really stupid and just say, I have this file, I have this offset in memory, I'm just going to put all the data in that file at that offset in memory, and then call the functions, and they don't have to worry about initializing anything else or setting any other data that says that they're using that particular memory. And all those values then are initialized to 0 just by copying the overlay in place, as opposed to copying n bits of the overlay and then knowing that m bits of uninitialized data or zeroed out data need to be zeroed afterwards. So it just makes the loader more efficient, easier to write and reason about. So we get 4 of those segments, just very generic. We have data, RO data. That's what the tooling will do. And then based on the PlayStation version, which has been completed except for a little bit of remaining data, I went through and was making the offsets for each of these and matching functions up. And for the HD version, we don't get a complete match on these. So we get a lot of new include ASMs. So we can look at, let's look at, which one is the most interesting? So this F890, this file is named based on its offset in the overlay. So for example, this entity platform function doesn't match what was used on the PlayStation version. And actually, let's go through and we can see why doesn't that match. I don't know if my context is set up to do that, but we'll see. So in previous streams, I didn't have a nice way of, I need to do the right overlay. So assembly is extracted into ASM HD, because this is the HD version of the game. Stage center, non-matching F890, which is our file. And actually for the HD version, this is not an offset F890. This name came from the PlayStation version. So I'm going to look at entity platform, and I think that will copy to my local buffer. In the past, I didn't have something that would copy over SSH for me. So I'm going to create a new scratch in decomp.me. Come on, new. There we go. PlayStation scratch. Let's see if we have the. Yep. We're getting the jump tables at the front, which is nice. We need to make sure that we're not including any macros or anything. That looks fine. So I'm going to create the scratch, and so the decompiler will run now and try to decompile that. What I'm going to do though is go back over here and grab the PlayStation version of this function. And I will do this offline. We're going to use that code to as the starting point instead of the instead of what the decompiler produces. I don't know if my internet is going slow or there we go. So there may be some variables that I need to define. But so the decompiler has gone through and attempted to decompile. I need a few variables here. I'm going to turn off built-ins. And then, so the compiler is saying I need a few other things. I'm going to just quickly look through and see which one of those are defined here that I can just grab from this file. And then we'll see how close it is and what changes we need to make it a match. In some cases, it's just that I have not mapped names to memory. It looks like pause enemies is new. So that's for unknown graphics struct. Somewhat interesting. So we have all these 32-bit values, and then we have a bool right in the middle. Most of the time what the compiler will do, it wants to align 32-bit values on 4-bit increments. So it'll pad this bool out to 32 bits, even though it only requires 8 bits. And the last one is this HGCS done, which I'm not familiar with at all. looks like it's a constant. All right, so we're already at 99%, which is expected. These shouldn't be too different. So going through and looking at the differences, immediate values we're going to skip for now. And really what I want to see is there actual code, or is it just symbols that haven't been mapped yet that's preventing this from using the original? So far it looks like it's a nice round number, so it may just be symbols that are different. That is all I see. So this one's actually very simple. The code is the same. We just don't have symbols mapped yet. So when data gets imported, we have to give names to different offsets in memory. None of that information is in any of the compiled files. And so by default, M2C is going to just give these things names based on their offset address in memory. And so then we go through and we give them friendly names. And those friendly names don't necessarily have information about their offset in memory. And so when we import something new and want to use the same code for places that use different memory offsets but the same variable name, we either need to make sure that that variable gets compiled to the same place, or to the right place in memory to generate the correct code with the correct offsets, or we need to go through and create a symbol file that has the name of that variable along with where we expect it to be in memory. And so a lot of what's left in this center overlay for the HD version is that. So let's, we'll get rid of the ASM inclusion, assembly inclusion. And, oh, I need to do a whole bunch. I can't just build this. So we export the version as HD. I'm going to clean extract, which is what pulls all the resources from the game binaries, and then we'll build here. And so this center overlay will fail, and it will either fail to compile, which is what I'm expecting, or it will fail to match. In this case, it failed to match. The other one, oh, it failed because I screwed up. I should have put this in. I should have done that before opening the editor, but we'll just have to remember to do it. So in this case, it's failing because the global entity init generic has not been defined, and that's because it's been given some random in-memory name based on its memory offset. And so what needs to be done is we need to go through, figure out what that offset is, and then assign this symbol that address. And we should be able to do that actually pretty quickly. So I'm going to open the symbols for this. This is a manually curated symbol list, and so we're looking for where is the G entity init generic offset. And the way I typically find that is to first look at the code and see where this is being used, and if there's anything, any hints that I can get. So for this entity platform function, it's the first argument to initialize entity. So I'll go back over and find where that is in Scratch. So that's on line 26. I'll go to my assembly, and because M2C has auto-generated names based on the memory address, I now have the memory address that I need. So I can take the name of that variable, go back over to my symbol file, add it here, and we'll see if this, I probably have to clean one more time and extract, but we'll try it without cleaning and see if that works. I'm going to, the driving file for the make is the splat config. Oops, I forgot to extract. Make extract. Make. Let's see, room darkness. Why is that being pulled in now? So let's clean. That's fine. So we're just gonna clean some with symbols and changes like that. The extracted assembly doesn't always get re-extracted with updated symbols. So that particular assembly file still had the old name. All right, and so now this is okay. So the only thing missing in that particular function was this symbol being matched, and now we have one more function that's matched there. So a lot of this for new overlays is relatively simple. It just requires some grunt work of looking up these symbols. Or there is a header that has basically all of this data, and we've already given names to all those things. And if we can use the C file in place of these auto-generated data extraction, we would get all that for free. In my experience, and there's probably people smarter than me who have a better workflow for this, working out the data and getting all those symbols in place first from C is harder than kind of going through this process. I had to go through and name 130 variables, assign them their offsets. And I still find that easier than going the other way around. I think that's kind of up to the person working on it. And hopefully, as tooling improves, that becomes less of a pain. Hey, Roaming, good to see you again. Yeah, that's actually what we did at the beginning. I was looking at your scratch and seeing what changes that you did make to get things closer. I'm not going to touch your scratch at all. But I wanted to see what progress, because yeah, it's almost done, and that's awesome. I think that first weapon binary should be done really soon. So that's all the time that I have for today. Appreciate people stopping on, even though I said I wasn't going to be here. If you want to know more about decompiling Castlevania Symphony of the Night, go to soten.z.dev. You'll see where the progress is. None of these HD files are included in the progress. I'm still going to be out here and there for the next week or so. So I don't know if I'll touch that at all, or if anybody else will look at it at all either. So you won't see this HD progress in there, but that's okay. You can see a lot of the PlayStation progress here. We've made a lot of really good inroads on a lot of the different overlays. You can see the source code that we have decompiled. There's a link to the GitHub there, where everything that's been decompiled is checked in. And then there's a link to the Discord server as well, where we're talking about decompilation, different things that we've learned about Symphony of the Night, and tooling for decompiling PlayStation games, of course. So if you're interested in any of those things, stop by the Discord, say hi. If you're interested in decompiling, there's lots of nice things in this repo, lots of low-hanging fruit still to get started and learn what the process is. So that's all I have for today. Thanks everybody for showing up, really appreciate it. And I will be back at the normal time tomorrow and on Thursday, and I'll see you then. Adios.